So please note that the class is now being recorded as we speak. I'm just gonna make sure that also the Teams it's also recording. Okay, the class is now being recorded as I speak. So today's lesson, I'm going to cover two lessons in one lesson due to the holiday that is coming on Friday. So each lesson will have a separate recordings. So there won't be one lesson, two lesson in one recording, but two lesson in two separated recordings. So today's lesson will be a continuation of what we covered in terms of lesson 12, which was the graphical illustration. So we covered this last week Friday where we performed graphical illustration. I'm not sure yet if you have managed to view the recordings. The links to the recordings have all been uploaded, so you can go and watch those. So under today's lesson, we'll be covering the difference between the histo and the bar graph, which are the main two types of bar graph that gets to confuse people when it comes to choosing which one to present based on the given information. Then after this, we're going to do a revision, which is going to be lesson 14, where we're going to be covering everything from lesson 11 to 13. But mostly we're going to also focus a bit on the briefing of your summative assessment as well as lesson 11 activities that will also form part a bit of your F1 assessment. So today's lesson, it's all about histogram and bar graph. These are the recordings that have been attached so that you can watch if you still need more understanding of those after the lesson. The learning outcomes and as well as the layout of this is that we're going to be discussing, or you will have to understand the bar graph and histogram, explain different types of a bar graph. You should be able to create a bar graph and histogram and then understand the difference between the histo and the bar graph. So these are the most important things that we're going to cover at today's lesson, and you should be able to achieve their understanding as well as explanation for those learning concept for today. So this is the revision of lesson 12, which I wanted us to actually do the stem and leaf plot in class, but unfortunately due to the request that we do the class online, so mostly I won't get to ask you guys to perform this, but I'm just going to explain the activity and how it gets to be performed. So based on the following activity, it says creating a stem and leaf plot activity, which is a revision of lesson 12. It says a number of journalists were asked to interview their community and find out the number of people interested in studying media and record it down. And the results were as follows. So one community had 21 people interested in studying media, the other one 35, the other one 42, the other one 11, the other one 13, the other one 77, the other one 14, up to the last one, which is 23. So these are all data collected in different communities. So based on the requirement is that you are required to identify the step followed when creating a stem and leaf plot. Second is to draw and display the stem and leaf plot for the data. And then the third question is to use your stem and leaf plot to find out how many journalists were interviewed their community based on the data given. So the steps that needs to be followed are as follows. Okay, something is a bit off, so let me just re-put this in a slideshow. Okay, there's still something off within my systems. So I'm just gonna check what's actually happening so that when I put it on slideshow, everything just goes back to full screen. Because now I can see my text bar is not disappearing on. So I'll just try to remove it. So here we are. So the first steps, coming back to our lesson, so the first steps in terms of creating a stem and leaf plot. So normally you can create a stem and leaf plot if you just only requested data to be collected and the data has to be numeric. So you cannot perform stem and leaf plot on word written data, but only on numeric data where you're working with numbers. And so when you do that, so you can be able to use what we call a stem and leaf plot. So the first part is that the first step is to rearrange the data starting from the lowest point to the highest point. So if you notice, based on our data this side, we've got 21, 35, 42, 11, 13. So our data is messed up and it's not actually not arranged. But if you take a look at this side, you will see that the first step have been performed. The data have been rearranged from the smallest to the highest. So the reason for the first step is to allow the second step to take place, which is to identify the types of place value within the point of data. So the place value is to identify how many numbers do we have in our data in terms of place values. So here you can see that our numbers here are within the tenth. So we only have 2 digits in all the numbers. So meaning that we can actually get now to create the third step, which is the groups, where we get to group the numbers based on the information provided, to say that we have got average or we have got place values that are within the tenth, not below the tenth and not above the tenth. So meaning that we can present our data in terms of tenth value, to say that if we have got all information the 10th value, so 1 will represent 10 and 2 will represent the 20th, 3 will represent the 30th, 4 will represent the 40th. So but if you have got data that is presented, for example, in terms of hundreds, and the value is like 120, 110, 115. So on your stem and leaf plot, you'll go and say 111 represent 110th values, and then 12 represent 120th values, 13 represent 114th values. Just like that when you're plotting your graph or when you're drawing up your stem. And then from there, once you create number 3, which is creating groups to be used based on average place value within the data, you then go and plot the data on the stem and leaf plot. And the most important part is that when you group your data, the width of your group must be the same. From 10 to 20, you will see that there is a difference of 10 from this group, to say that, meaning that data that will be presented from the 10th will be from 10 to 19, and from 20 to 29, 30 to 39. So we've got the same values in between the groups. So meaning that our data will be able to allow us to have comparison. So based on that data, so this is the steps that will be followed when plotting the data. So some of the information here is missing. So if we go back here, so you will notice that here we've got 11, 12, 13, 14, 14, 15, 16, 17, 18, 19. So meaning that on the value of 10th value, so we're going to have 11, 12. So the leaf represent the value plus the stem. So the stem is representing the 10th value. So meaning that if we put 1 here, we're saying the stem plus the leaf, which means that this is going to be 10 plus 1, which is going to be 11. 10 plus 2, 12. 10 plus 3, 13. 10 plus 4, 14. So meaning that the data doesn't get to be lost when performing a stem and leaf plot. So here you're gonna see that we've got 11, 12, 13, 14, 14, 15, 16. But on our data this side, you will notice that we've got 17, 18, and 19, which is missing. So you're gonna go and add 7, 8, and 9. So you're going to add all of those data that are missing. Then you're going to move towards the 20th to say that what are the values within the 20. So the value within the 20, we've got 21, we've got 22, we've got 23, we've got 25, and we've got 27. Meaning that on your leaf, you're going to have 2, 3, 5, and 7. And the 2 become the stem. So this is how you present your data. And then the last part is to say that based on the
Sir,
requirement. Yes? Any question? Is there someone who have a question?
I think you muted.
Uh, Let me just quickly check that.
Sir, are you aware that you're on mute?
Sorry about that, guys. I just noticed I have got two devices open right now, which I've got the other one on the other side for audio, and I noticed that the mic was on. I thought everything was okay, so my apologies for that. So what I'm just gonna do is that I'm just gonna go back a bit. So I'm just gonna quickly elaborate what the lesson is all about, and then we can start. And thank you very much for that. I wouldn't have noticed, but the other recording managed to take everything up except the Teams one, and you guys didn't manage to hear anything. So I was busy explaining that today's lesson is all about the bar graph and histogram, which is lesson 13. The difference between the two, the histo and the bar graph. And then I was also saying that on lesson 14, we're also going to cover lesson 14 today, which is going to be a revision of lesson 11 to 14. And also, I'm going to brief you guys in terms of your summative assessment, what you should be expecting on your summative assessment. So meaning that once you are done with your F1 assessment, which is your formative assessment, make sure that when it comes to the summative, you prepare in advance, you pre-read in advance, because this one is going to be the one that determines whether you'll be successful or not successful in the module combined together with your F1. So this is the lesson outcome for today's lesson. So it's understanding the bar graph, explaining the different types of bar graph, creating a bar and a histograph, which we're not gonna focus much on, but I'm just gonna elaborate on some of those type of graphs that we can actually get to draft, understanding the difference between the histo and the bar graph. So this was the activity that I was busy explaining while the recording was muted. So under this activity, it's based on previous lesson, which is lesson 12 activity, lesson 12 lesson, where we talked about the stem and leaf plot. So under the stem and leaf plot, I did mention a number of things to say that the stem and leaf plot can be used where we've got data that is only presented in numeric form, and rather than in verbal form where it's only words or numbers are only words written, or scenarios. So only when you have got data that is being collected that is numeric, then you can actually use a stem and leaf plot, and the data doesn't have to be too long, and the data have to be at an average pace, like it have a minimum number set which you can be able to rearrange and sort. But if you're having large data, you cannot use a stem and leaf plot. So under this activity, it was saying that a number of journalists were asked to interview their community and find out the number of people interested in studying media and record it down. So this was the task given to journalists, and the results were as follows. So this activity, we were supposed to perform it in class. So we're supposed to perform this activity in class. So unfortunately, due to online, I'll just be explaining the activity. So, and then here you have got your data from 21 up to 23, which have been listed. And the requirement for this scenario is that you should identify the step followed when creating a stem and leaf plot. Draw and display the stem and leaf plot for the data. Use your stem and leaf plot to find out how many journalists interviewed their communities. So the first step that I was busy explaining is this one, which is the first requirement, which is identifying the step followed when creating a stem and leaf plot, which the first step is to actually get to rearrange the data set. So our data here is based, the previous data you will see that it was saying 21 up to 23, which is a mixed data. So the most important part when you're working with stem and leaf plot, the first step that you do is to rearrange the data from the smallest to the highest. Second step is to identify the place values. In terms of our data, we've got 13 numbers that are within the 10th, which are 13th, 20th, 30th, 40th, so and up to 91. So these are all the data that we have in our scenario. So we don't have anything above the hundreds or to the thousands or millions. So meaning that these data sets can actually get to be worked within what? A stem and leaf plot. So our place values are within the tenths. So you can see that we've got only 2 digits that are within the 10th value. So meaning that we can move towards step number 3, which is actually creating what you call groups. So when you create groups, the width of your groups have to be the same. So meaning that to say that if we're to say we're gonna have the place values, the stem of the 10th, the stems of the 20, the stem of the 30. So the numbers that are to be included within these stems, they have to be the same in terms of the width. To say that if we're taking a look, since all our values are within the 10th, so we can represent our data by the following method. To say that we're going to have 0 from 0 to 9. There's values from 10 to 19. The value from 20 to 29, the value from 30 to 39. So we're going to have those kind of data. So meaning that the gap in between the width within our groups are actually the same. So if our numbers are within the hundreds, so we can actually get to also create groups that are within the 100, to say that if we have got values from 100, 110, 120, 130, 140, so we can go and say 1 or 10 will represent the values within the 100, 11 will represent the value within the 111th to 111th to 119, and then we're gonna have 12 representing the values of between 121 or 120 to 129. So this will be the stems that will actually create. So when you create groups, the groups are what we call the stems. So these are the stems within your diagram, and then from there you're gonna go and plot your data based on the stem and leaf that you actually created, the based on the stem that you created, and then you put the data within the leaf. To say that since here we've got 11, so meaning that on this side we're gonna have 1, and since here we've got 12, this after 1 we're gonna have 2. So this is all shown here within this statement to represent the data that we have. So if you notice, we've got 11, 12, 13, 14, 15, 16, 17, 18. So all of this data, this time have been identified, or we have identified the groups to fall within 1, 2, 3, where all these 1, 2, 3 are representing the 10th value. To say that 1 represents the 10th, 2 represents the 20, the 30, the 40, the 50, the 60s. And then from there, meaning that any value that falls within the 10th will be represented here or written here based on ascending order. So we've got 11, so meaning that on the leaf we're going to have 1. And once you have 1, meaning that it's saying that when you read the data, it's going to be 11, which is the 10th value, which is 10 plus 1, 11. 10 plus 2, 12, 10 plus 3, 13, 10 plus 4, 14. So if without doing that, you can just say this is 11, this is 12, this is 13, this is 14. So when you get to use a stem and leaf plot, your data does not get to lose you don't get to lose any value within the data, and all data will still have its own significant value within the stem and leaf plot. You can still be able to identify the value that was used within the data. And if you notice some of the things here, it ended at 6, and based this side it was saying 16, 17, 18 and 19. So we had to add the 7, 8 and 9 within our stem and leaf plot. And where there is no data, like for example 60s, if you come back to this data, you will notice that we don't have any value within the 60s. So you just skip this part. You don't put a 0. If you put a 0, you are saying that there is a value of 60. So if there is no value, you skip. You just let it as it is and you skip to the next. We've got values within 72, within the 70s. So therefore the values within the 72s, we've got 72 and 77. So you will notice that here we've got 72 and 77 within our data. So therefore, we can actually get to plot something. Where there is nothing, we skip. And then the last part of our requirement, it says use your stem and leaf plot to find out how many journalists interviewed their communities. So what they're asking you is to identify the number of leaves that are there within the stem and leaf plot, which will also represent the total number of data collected by each individual journalist. To say that this 21 represent one journalist number recorded, to say that 21 represent the number of people in one journalist community that are interested in studying media. 42 represent another journalist number that he or she recorded based on the number of their community members that are interested in studying media. So you can actually count this by saying 1, 2, 3, 4, 5 and get the total number of journalists that conducted interviews. Or you can actually use the stem and leaf plot. So the activity required you to use a stem and leaf plot to calculate the number of journalists who interviewed their communities. So when you do that, you're going to calculate the leaves. So each and every leaf represent a number of journalists that actually interviewed their community. To say that we have got 11, this one represent 11, so meaning that this is going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the first stem have got 10 leaves. So once it have 10 leaves, this 10 leaves means that there are 10 journalists that interviewed their communities and their results are represented within this stem of 10th value. To say that the first journalist represented had a count of 11 people, 12, the other one 12, the other one 13, the other one 14, the other one 14, the other one 15. So leaves represent the number of data being used as well, which means on our case we'll also be representing number of journalists that conducted interviews. So the first one I've got 10, second one I've got 1, 2, 3, 4, 5, which is also listed on this side, but you will notice that our data here have been cut short when I was preparing the slide. So it was supposed to say 10 leaves here, and then 5, 4, 1, 1, 2, and 1. And when you add all these leaves, they will add up to 24, which means that 24 journalists conducted the interview. So when we go back this side, when you count all the number of data collected after rearranging them, you will still get 24. So you are still supposed to get 24. So any question based on the activity? Guys, any question? Guys, any questions? Okay, let's
No questions, sir. I just wanted to ask because I'm still trying to catch up. I'm a bit behind. Where's this in the textbook? Because I've been trying to find it.
on the textbook, I think it's page 100 and let me just get the page for you right now.
One 178.
Sorry, 170?
It's 145.
Okay, thank you.
So this is part of lesson 12, which is starting from page 145 up to page 164. So our lesson ended 164, which also include lesson 13. So lesson 12 and 13 start from 145 to 164, which is graphical illustration.
Okay, I was actually on that page, but I couldn't find the actual activity. Where is it? Because even at the end here, it's not there.
No,
The specific.
this was supposed to be a class activity. As I mentioned earlier, you were supposed to perform
okay.
it in class. So it's not on
Oh,
a textbook.
okay. Thank you.
Yes. All right. So then we can start with our lesson, bar graph versus histograph. So mostly this have already been covered in terms of lesson 12, but I'm just gonna just only pick up some few points, and then from there we can discuss everything relating to bar and histogram. So here we've got a bar graph. So a bar graph, it is said that it is a chart or graph that represent categorical data with rectangular bars with height or length proportional to the values that they represent. And the bars can be plotted vertically or horizontally. And as you can see on the other side, on the right side, we have got an example of a bar graph that is represented vertically. And then it also says that a bar graph shows comparison among discrete categories, and one axis of the chart shows the specific categories being compared, and the other axis represent the measured value. So depending on the type of way that you're going to plot your graph, whether it's vertically or horizontally, therefore your x-axis will not be the same if you choose the two method. So when it is vertically, like the one that we are seeing here, you'll notice that your x-axis, which is this side, will be the measured value, and then you'll see that your y-axis, this side, will actually be the categories which are being compared against each other. To say that based on the people that uses the following type of transport, either for leisure or work, to say that all responded total to 259. So meaning that 259 people were interviewed. And from those 259, the ones that use bicycles, the following percentage says they use it for work, the following percentage says they use it for leisure. So meaning that we can actually get to calculate based on that. And then we can also get the train people, to say that people use train. Uh, Close to 40%, which is 38%, actually uses it for what? For work, for leisure, which is the blue one, and then the light blue, which is somewhere around 35. I use the train for what? For work purpose. So it allows you to actually compare also data. And then again, on terms of bar graph, we have got different types of bar graph. The one that is represented here, it also referred as what you call a cluster bar graph. So a cluster bar graph is when one category actually have two different types of information being compared to each other. And then we've got an ordinary bar graph. An ordinary bar graph, you'll only have one line item here. So meaning that one category is no longer being compared against only just it's not compared. There are no multiple categories in within one. To say that, is example, we have got the bicycles. So the bicycle have got two types of category within it. We have got leisure and work being compared against each other. But again, on a normal bar graph, it will only be the bicycle being compared to train. So it will be category versus category. But in terms of the cluster, we are saying that for each and every category, there are a number of items that are being compared. So therefore, it will allow you to show those comparison. And then one of the main features about the bar graph are as follows. The width of the bars must be the same to allow fair comparison. So from this point to this point, it have all to be the same. So you don't have to have a bar graph that actually have the other one being slim, the other one being thick. So all of them have to be the same in terms of the size. And then again, the distance between the bars must exactly be the same from this point to this point, and from this point to this point, and from this point to this point have to be exactly the same. And then again it says that the gaps shows that the horizontal axis is not continuous but represents section which are categories. And then the vertical or horizontal axis must be labeled to say that this side is movies and this side is people, number of people. And also a title should be added. If you take a look at the one that we had this side, you will see that these are types of transportation, these are percentage of responded, and the title of the bar graph is the follows: transportation method used on regular basis. And then this side you will also see the number of responded, the purpose of the types of bar graph listed within. And then you will have your bar graph fully labeled and all main features included. Also, one of the most important thing is that the same features that are used within the bar graph or some of them are also used within the histogram, except the one where we're talking about gaps, the distance between the bars. So in terms of the what we call histogram, we do not have gaps. So in terms of the histogram, we do not have gaps, and the histogram is a graphical representation of data points organized into user-specific range. So the difference between the two is that on this side under the histogram, we normally do not have categories but range of data. So meaning that most our data are all collected based on numeric values. So we are actually comparing the numeric values against the data collected. So now coming back to this, it says similar in appearance to the bar graph, the histogram condenses a data series into an easily interpreted visual by taking many data points and grouping them into a logical range of pins. And the height of the bars shows how many falls into the range. So, and you decide what range to actually get to use. So as you can see from this side on the example, it's showing the grade on English test that the students score. Those who scored between 40 to 50 are somewhere around 13. Those who scored between 50 and 60 students, we have got something like 23 students. Those who scored between 60 and 70, we have got 35 students, and those or 33 students. Those who scored between 70 and 80 are actually 45 students. So we've got 45 students. So meaning that if your data is based on also numeric data, then that's when you can actually get to use the histogram. But if your data that is being collected is based on categories, so for example, it's based on words to say that number of people who've done this, or it's based on to say people who actually do this, people actually do this. So an histogram can never be used on that type of data. So to be best is to say that if you remember based on lesson 12, I did mention that we've got discrete and continuous data. So when we have got discrete data, so the discrete data can be used to actually get to be presented in the bar graph, but non-discrete data, which is also known as the terminology that is there. I was just looking for the terminology, the discrete data. So non-discrete data, which is continuous data. So continuous data can be used under the histogram. We can use the continuous data to plot it under the histogram. So on the next slide, we're just going to be talking more of the difference. But after the difference, I would just like you guys to mention any things that you would like us to add within the difference between the histo and the bar graph. So these are the difference between the histo and the bar graph. So in terms of the histogram is a term that refers to a graphical representation that shows data by ways of bars to display the frequency of numerical data. And in terms of bar graph, the bar graph is a graphical representation of data that uses bars to compare different categories of data. So those are the first two differences within the tools. The other one uses categories, the other one uses frequency. And in terms of histogram, it uses non-descriptive variable, and then the bar graph uses discrete variables. And then in terms of the histogram, again, bars touch each other, but on the bar graph, the bars do not touch each other. And then again, in terms of the histogram, elements are grouped so that they are considered as range, but in the bar graph, elements are taken as individual entities. So we get to specify them as categories. And continuing with the difference, the width of the histogram bars might differ, but under the bar graph, the width of the bar have to be the same, and the distance between the bars have to be the same. But in terms of the histogram, it's not the way it's supposed to be. And in terms of the histogram, it displays the frequency of occurrence, whereas the bar graph only shows the categories of data. So meaning that if you have got trends like using continuous data, so continuous data allows you to actually see the trends between data. So meaning that you can actually get to use a histogram because the frequency of occurrence can actually get to give you a trend in terms of how data would actually be. So you can actually use it to predict future data, whereas the bar graph does not allow that because everything is a category. And then in histogram, data points are grouped and rendered based on bin values, whereas in the bar graph, each data is rendered as a separate bar. And then again, the histogram, we cannot rearrange the block, but then again on the bar graph, it is common to rearrange the blocks from the highest to the lowest because each and every bar represent a separate category. So meaning that we can start with a category that have got the lowest data. So meaning that when we present our information, we can actually get, it does allow us to go and say that this is the following information starting from the lowest point to the highest point. But whereas on the histogram, you cannot rearrange because when you're working with range have to go by the sequence or the ascending order or either descending order of the range. If one range have got the smallest and the other range have got the highest, you cannot change that. An example will be this one, to say that if we were to say let's start with the student that scored the highest followed by the second highest, we cannot start our range by saying 70 to 80 and then we said 80 to 90 and then go and say 60 to 70. So it will no longer get to make sense because the frequency have to go by ascending order. So meaning that we cannot rearrange this based on the lowest and the highest. But in terms of the bar graph, since this will be written as a category, therefore it can actually be put at last or at the beginning since they are not going to be attached to each other. So we can actually start with the category of students that are that scored above 40, that scored above 70 but below 80. And then we can create a category for students that actually scored between 90 and 100. And then we can separate them and put them as a category. And then we can actually place them within the height. But once we use a histogram like this where data is attached and the sequence is following, it's using the frequency of 40, 50, 50 to 60, 70 to 80. You cannot rearrange from smallest to highest. So just based on that, I would just like to know from you guys what you picked that are the advantages and disadvantages of the histo as well as the bar graph. So let's start with the bar graph. What are the advantages of the bar graph that you have picked up from the differences? I'll start with, I'll just be picking up names. Let's start with Rhea. One advantage that you picked up from the bar graph that makes it an advantage to use. Rhea, are you alive? Are you around? Okay, I see there is a lot of silence there. Let's move to CBC. Any advantage that you picked up from the difference? Advantage of a bar graph?
I think the spaces in between makes it easier to read other than a histogram where everything is touching.
Okay, that's one advantage. And then let's hear Zama. What is the advantage of a histogram? One that you picked?
The fact that like it can be stacked or clustered. Yeah, I think it makes it better in terms of like comparison in when you're comparing like multiple variables.
Okay, that's one advantage. And then let's hear from Ipeling. What is another advantage of histogram? Ipeling? Okay, not around. And then Nompumelelo, a bar graph. Nompumelelo around. Or Mpumelelo, sorry, Mpumelelo, not Nompumelelo, Mpumelelo. Sima, can we have an advantage of a bar graph?
Okay, I think one of the advantages is that if you are dealing with providing specific data in exact details, then a bar graph is more accurate to use.
All right, that's 100% right. So let's just take a look at some of the advantages that maybe some of them you pick them up, right? So these are other advantages of a bar graph. So you can use the bar graph with numerical or categorical data. So this is the advantage. Data that can be presented using a histogram can also be presented within the bar graph. So that is the advantage. That's the first advantage. The second advantage is that the bus displays each data category in a frequency distribution. So you can uh, actually reorganize the category based on your understanding of data, which once of you guys actually mentioned that it is easier to actually understand and to also place the data based on your understanding. And then the third is that it shows relative number or proportion of multiple categories. So unlike the histogram, you cannot have multiple items within one range being compared to each other. So mostly we normally have this within the bar graphs. It also estimates the key value at a glance and then also display close numbers or proportion outline, and large data set is in the visual set in the visual form helps you to clarify trends better than a table. So these are the advantages of the bar graph. And then the advantages of the histogram are that it helps you display a large amount of data which is hard to interpret in a tabular form. For example, if you have got a total number of list of students that scores between the following amount, or you actually want to compare numbers of or to say people of ages of viewers of your TV shows. If you are running a TV show and you actually want to identify people who view your TV shows based on ages, so it will be much easier to use a histogram because you will have a range of age to say from 0 to 10 years, from 10 years to 20 years, from 20 years to 35 years, just like that, to say that these are the numbers of viewers that we have based on the certain age, and these are our subscribers based on the certain age. So it allows you, if the large number of data is being collected, so you can use a histogram, and it uses the frequency of occurrence for the different data values, which I just also explained, and useful when calculating the capability of a process. So it allows you to draw a trend and actually get to estimate based on the range. Since all your information is within a range, you can actually get to put an estimation to say that within this range we can expect a certain value. But in terms of a bar graph, you could only be able to compare if there are multiple items being compared within one category. And the histograms allows you to show the frequency of occurrence for data along with an interval. To say from the highest to the lowest, this is the interval. So this is still below our mean, this is still below our average kind of information. And these are the disadvantages of a bar graph. The bar graph display only the frequency of an element of a data set, and you need additional explanation with a bar graph to say that this bar, if you actually mostly you will need additional explanation if you are working with a what you call a cluster bar, where you have got multiple bars within one category. So meaning that you will still need to explain what each and every bar means within that category and what is it measuring. But in terms of the histogram, since it doesn't have such, so we won't have such a disadvantage. So meaning that you'll have to plot all of them, and then if it fails to reveal the key assumption, causes, effects, or a pattern. So you don't get to see a pattern in terms of the bar graph, because it only shows you data for a specific period and the trends within that only specific period. But to see a pattern going continuously pattern, you won't be able to see that continuous pattern. But in terms of the histogram, these are the disadvantage. It does not allow you to read exact values because data is grouped into categories. So we've got a range to say from 40 to 60 or from 10 to 20. So you do not know who get actually to manage to score 15 or how many people are within the age of 22, because you are just having a range from 20 to 25 years or 20 to 30 years. So it doesn't give you the exact value of number of people who are within a specific category that you're actually looking for, a specific category item that you're looking for. It only uses continuous data, which continuous data allows you to be able to see the trends. And then in histogram, it is not easy to compare two data sets. So we cannot compare two frequencies to say from 40 to 60 and 60 to 70, because we'll be comparing two different things. You cannot compare people who are having the age of 40 with the people who are within the age of 60. The comparison will not be fairly enough because of the factors that plays around within those people. And then the use of intervals in a histogram prevents calculation of an exact measure of central tendency, since it's using an average or frequency. And this is sort of like an example within the histogram. So this is the difference in terms of the histogram. And you will see that in terms of the bar graph in the histogram, the other one have gaps, the other one doesn't have gaps. In terms of the x-axis, if it's being labeled, the other one will have categories, the other one will have number range, to say from 100 to 150. The other one will just have data categories, to say USA, UK, South Africa, SA, Japan, Brazil, just kind of those stuff. So you will see that you will have different setups. And you will see also the width of the data within the bar graph are the same. And then in terms of the histogram, it won't apply since everything is connected to each other. And then we can rearrange the bar graph and start with the highest to the smallest. Whereas on the histogram, if you notice, since we have got range from 100 to 150, 150 to 200, 200 to 50, we cannot rearrange this because it will no longer make sense. Because if the following data was coming from the highest to the lowest, we're going to start with 250 to 300. And then from 300, we're going to go and say 200, which is going to mess up our data. So we cannot rearrange on the histogram. And then lastly are the types of bar graph. So these are the types of bar graphs that are available. We've got 5 types. We've got, it's 4 types. So I've limited them to 4 types. It's supposed to be 4. They mentioned 5, but when I take a look into it, it's actually 4. So it's horizontal bar graph, vertical bar graph, grouped or multiple bar graph, and we've got a stacked bar graph. So in terms of the vertical and horizontal, this could not, if I was to classify this, I won't identify these as types of bar graph. I will identify these as ways of drafting a bar graph, to say that there are 2 ways which you can either put your graph either horizontally or vertically, which is not a type. The only way I will say that there are types is to say that we have got a single bar graph and we've got a multiple bar graph and a stacked bar graph. So meaning that in reality we only have 3, and then we've got 2 ways which these 3 can actually be plotted, to say that we can actually either plot them vertically or horizontally. And then those 3 types are single bar, multiple bars, or stacked bar. So if you take a look at the following data, this is one for horizontal and vertical. It's only representing, so here we've got, there is a bit of an error here. This is supposed to be pointing upwards, so our bar graph are supposed to be facing upwards, not downwards. And also the numbers of employees were supposed to be, this bar graph is supposed to be the other way around, which is by the way it's looking, it's supposed to be minus 90 degrees, so anti-clockwise. So this is how it was supposed to be setting. So it says that, so I'm just gonna show you based, because this is already a vertical bar. So since it's a vertical bar, you will see that from our vertical bar, you will have the numbers of employees and the savings from this side. So we're actually getting to measure savings of employees and people to say that the following numbers of employee managed to save 20%, 30% of their salaries. So this is how the data gets to be represented. And then I won't focus much, so I just wanted to focus more on to say that this type of bar, this is what we call a single bar. So this is why I'm saying that I will only have three types to say that this is a single bar and this is a multiple bar. So in terms of multiple bar, this will be the multiple bar, which is a grouped bar. So meaning that for January, you'll have multiples bar within or grouped bar, which we also referred it as a cluster bar graph. So it's also a cluster bar graph. So normally when you're working with information where you get to compare multiple items within one category, for example, under this information, you are given month and you are given different types of product that are being sold within this company, which are all shades. To say we've got three types of shades. These are the total number of units we sold within the month of January, February, March, April, continuously just like that. So meaning that on January we can perform what we call a grouped bar or a stacked bar, which means that if we perform a multiple bar or a group bar, we can actually get to compare the number of shades within January, which is the category, and February category, so which can be listed as this method. And then we can also list this as a stacked bar, which is the third type of bar, which I will say that there is, to say that where the other information stop, if there is another item that is above the other one, we'll show it based on the other color, and then the one which is the highest will be the one on top of the rest, because it's going to be starting from 0 to the highest point, to show that sales for shade 1 are this much, then on top of that, that is the second highest, and then that is the third highest. So we can actually stack them based on their data collected, or we can present them based on the following method. So this is method or ways we can actually get to present data, whether stacked or cluster bar. So as long as data allows comparison within one category, you have two choices: use either the group or the stacked. You will still be correct. So I think these are everything that we had to cover. Any questions? Yes, this is everything. Any question? So I'll assume that there are no questions. So this will be the end of lesson 13. So I'm just gonna open up lesson 14, and then from lesson 14 I'm gonna start by briefing you in terms of your summative assessment, and then we're gonna do a revision of everything from lesson 11 to 12. Sorry guys, I just got hit by load shedding, so my router just went off. So I just went it on to the next router, which was on standby. So my apologies for that. So I was still asking if you guys had any questions. So any questions? Okay, in absence of questions, what I'm gonna do is that let's move to the next lesson. So I'm gonna share the next slide lesson, which is gonna start with a briefing. So let me stop the recording and do another one so that we have got two different recordings.